Today we will continue practicing how to simplify algebraic expressions, looking more closely at the concept of like terms. So let's get started. So in the previous lessons, we briefly discussed the like terms. And I said that a like term has the same variable raised to the same power. A like term is any term that has the same variable or variables. It can have multiple variables in it. And each one of those variables will have the same base raised to the same power. So if we look at this first line, we have the like terms 6x and 2x. The numeric coefficient is irrelevant. These could be any numbers. But then we have the variable x, and this is raised to the first power. And then for the second term, we have the coefficient 2, and then the variable x raised to the first power. So we have the same base, the base is x, and the same exponent. In this case, the exponent is 1. So as we move across here, we have 6x and 2y. Again, we keep these coefficients the same. These can be any numbers. But here we have a base x raised to the first power and a base y raised to the first power. So the exponents are the same, but the bases are different. So these are not like terms. Looking at this second line, we have 6z squared and 2z squared. Again, the bases are the same. We have a base of z in both cases, and the exponent is the same. Exponent of 2, both of these are raised to the power of 2. So we have the same variable raised to the same power. These are like terms. But we move across, and now we have 6z squared and 2z cubed. Same base, they're both z, but the exponent is different. The first term is raised to the second power, and the second term is raised to the third power. So these are not like terms. And for this third example, we have 6ab squared and 2ab squared. We have the variable a raised to the first power in the first term, and the variable a raised to the first power in the second term. Those are the same. And then the second factor is b squared. So we have the base b raised to the second power in the first term, and the base b raised to the second power in the second term. They are both ab squared. Moving across, we have the first term of 6ab squared, but the second term is 2a squared b. So instead of having a to the first power like we have in the first term, we have a to the second power. And in the first term we have b to the second power. Here it's b to the first power. So these are not like terms. Now just a reminder, if there are no variables and we just have constants, we have numbers like 6 and 2. So these are like terms. Whereas something like 6 and 2x, again, this second term has the variable x raised to the first power, but the first term did not have any variables. These are not like terms. This is what we were mostly looking at in the previous lesson. And when using like terms, they can be combined with addition and subtraction. So we can add or subtract like terms. So let's practice a few. So when we simplify algebraic expressions, and again we saw this in the previous few lessons, we simplify these algebraic expressions by adding or subtracting the coefficients of the like terms. So let's start by finding the like terms. So in this first one, we have x and 6x. They both have the variable x raised to the first power. So I'm going to group those together. It's x plus 6x. And then we also have terms that have the variable y raised to the first power. So we have negative 3y and 2y. And we can group those. So negative 3y plus 2y. And then that leaves us with 5 plus 5. We'll go ahead and group our constants. And now we will combine our like terms. So this is x plus 6x. That's 7x. We added those coefficients. Negative 3y plus 2y. That's going to give us negative 1y, which we can write as minus y. And then 5. In this second problem, our terms contain z squared and z. So let's group our z squared terms first. So we have 7z squared. We have a negative 3z squared and plus 1z squared. So 7z squared minus 3z squared plus z squared. For z to the first power, we have that 4z and minus z, or negative z. So we have plus 4z minus z. So we've got them grouped. Now we can combine these like terms by adding or subtracting the coefficients. So 7 minus 3, it's going to give us 4z squared plus z squared plus 4z minus z. And then 4z squared plus 1z squared, that's 5z squared. Plus, and then 4z minus z is 3z. In this third problem, we have x raised to the second power, so x squared. We also have a y squared, and then a couple constants. So let's go ahead and group our like terms. We'll have 8x squared plus 3x squared minus 2y squared minus 3 plus 11. And then 8x squared plus 3x squared, that's 11x squared. Minus 2y squared, there's nothing to combine with, so we'll bring that straight down. And then minus 3 plus 11 is plus 8. So in this fourth problem, we now have two variables in each of our terms. This first term has a squared b. The second term has ab squared. So these two are not like terms. The variables are not raised to the same power. We look at this third term. That's ab squared. That's the same as the second term. So the second and third term in this expression are like terms, and they can be combined. And then the fourth term, a squared b, goes with the first term. And these are like terms that can be combined. So one thing I do sometimes is as I use a term, I will cross it out. So I'm going to start grouping the like terms. And as I group them, I will cross them out from the original expression. So I'll bring down the 2a squared b. And I'll kind of cross that term out. I know I've used it. Well, then I'm going to bring down this plus 3a squared b. And I'm going to cross that term out. I've used it. So now we'll do plus 5ab squared. I'll cross that term out. And then minus 3ab squared. All my terms are crossed out. I know I have included them in this grouping. Now we'll combine the like terms. 2a squared b plus 3a squared b. I'll add those coefficients. That's 5. Then a squared b. And then 5ab squared minus 3ab squared. 5 minus 3 is 2. So we have plus 2ab squared. A great way to learn is to practice on your own. We will discuss in a bit, but go ahead and pause your screen and do these 4 problems. So on this first problem, we only have one pair of like terms. The 5x can be combined with the negative 8x. The result is 2x squared minus 3x plus 4. So in this second problem, we have 3 different groupings of like terms. We have a group that has the variable x raised to the first power y cubed. Another that has the variable x raised to the third power and y to the first power. And then a third group that will have just x to the first power, y to the first power as factors. So our groups are x cubed y has those 2 terms. xy cubed has those 2 terms. And then we have a single term with xy. We combine those and we end up with 3x cubed y minus 4xy cubed minus 2xy. So the process is the same whether we have integer coefficients, fraction coefficients, or decimal coefficients. We're still going to combine those like terms. So in this third problem, we have like terms that are x squared. There's one grouping of like terms. Another group that has x to the first power. And then our constant 1/3. And just like before, when we add or subtract fractions, we need to get a common denominator. In this case, it's 10. The end result is 1/10 x squared plus 3x minus 1/3, minus 1/3. And finally, working with decimals, we have one y squared term, a couple y terms, and then a couple constants. We end up with y squared plus 4.6y plus 1.4. Continue practicing simplifying algebraic expressions, and I'll see you in the next video.